Hello, I'm Eric Snodgrass, and thank you for watching today's in-depth ag forecast brought to you by Nutrien Ag Solutions. I'd like to start off the video having a quick discussion about La Niña. I'm going to talk about the performance of last year's forecast for spring. I want to get into some of the differences for this spring, and then we'll move into the high-impact winter storm that's going to come through the midsection of the country this week. So you've been looking here at a graphic that shows you from the IRI group out of Columbia University what their forecast is for ENSO. So ENSO stands for El Niño in the Southern Oscillation. So when you look at the blue bars, they represent the La Niña forecast probability. So, of course, this late winter into spring, we still have La Niña. But what you can see is that it's fading quickly as we go through our late spring into summer months. And at that point, the probability shown in these gray bars, which is the increase in the chances of it being a neutral situation in the Pacific, increase. What you're finally going to notice is that beginning here, May, June, July, and then pressing through late summer into fall, that's when our increased chances of having an El Nino return. So I bring this up because I've been getting asked a lot of questions. Are we going to see a third year of La Nina? And the probability of that occurring is very, very limited. Now, I say third year, which means we had one the previous winter, this winter, but not next winter, okay? But I want to go back to last winter for a moment because the long-range forecasts released last February for March, April, and May of 2021 look like this, all right? Wet in the Pacific Northwest, wet here in the Midwest, getting toward the Great Lakes through the Ohio River Valley, and then dry from parts of Mid-Atlantic all the way through the plains and back to the Four Corners states. Now, anybody that studies this would go, that is a La Nina spring forecast if I ever saw one. But remember, La Ninas fade in spring, and they're no longer the dominant driver on the precipitation or temperature patterns once you get into March, April, and May. And just to show you how the models perform, because the European model looked very similar to this, okay? This is what we actually got last year. So the West was very dry. The northern plains, major snow drought in this area. Look at this part of the Great Lakes getting into most of New England here, including down here into the Mid-Atlantic and the Carolinas. We were very wet here, eliminating the drought concerns we had. And that forecast said it should look like this. That's almost a complete 180 over what was forecast, right? Now I want to show you some of the differences this year compared to last year. So a year ago, we had a fading La Nina, and there was a lot of discussion about this, that cold water that's in what we call the Pacific Meridional mode. That's when we talk about the cold water coming off the Baja. Our La Nina was way out here in the Central Pacific and already starting to show a warming trend over here by South America. Now what's different is this. That's our current La Nina. Instead of having cold water here, we've got cold water in the Gulf of Alaska. Instead of having a La Nina that's way out over here, our La Nina is more east focused. So see the differences already between last year and this year? What's interesting about all of this is the forecast for this upcoming March, April, and May. And I'm just going to make a statement. Does not look familiar. This was a year ago, and this is the new one for this year, March, April, and May. You see, this is when we talk about how the models are so hung up on ocean temperature patterns driving things. This is what I'm talking about. Now, the question we have to ask is there any chance that this verifies? Is there something different? Because I showed you the ocean temperatures. Is there something else that's different that may lend more credibility to this forecast compared to what we saw a year ago, which was very bad for spring? So let's talk about that. First of all, our year-to-date precipitation compared to average. We have places in the West that have yet to measure precipitation this winter. We've noticed, and we've talked a lot about this, there's a large area that is without snow here, and there's also a corridor in through here that's been very dry as of late. Now, the southern plains have had better precipitation really from this point east with time, and we've done a lot to kind of cure any drought issues we were thinking about in the Carolinas toward Virginia. That's really gone away. Thinking about that snow, this is percent of normal snowfall through this morning. Now, we know down south we don't need to look at this closely. We're going to look at more closely to the north. And I'm just want to point out that a lot of the, this part of the central Mississippi River, but almost the whole of the Missouri River, either doesn't have snow on the ground right now and throughout this season has been in snow drought. We can also see what's going on in New England, another place that's missed out on it. And even though you see all the blues that are over here in the West, the vast majority of this came in December. So I'm asking myself, what's different now than a year ago? Even though the forecasts look the same, is there any chance that this forecast verifies? Well, here's the first thing I want to show you. Now, I know you're looking at this going, what the heck? I'm sorry, I should have taken the time to graph this, and I just didn't have time. You're looking at the MJO phase. Now, this is, the twos here represent February, and here's March, okay? What I want you to see is a year ago where the MJO was at this time. It was in the month of February in phase 7, 6, 5, 8. It was on a certain side of the diagram. In fact, let's just go look at it. It was way over here. Where's our MJO right now? Phase 3. And this has been something we talked a lot about. It's likely going to stay in phase 3 for a while and maybe eventually pop out into phase 4 and sweep around to phase 5. So if that happens, what does that mean? What do we get if the MJO starts to swivel around like that? Because we look at the upper levels of the atmosphere, and from now over the next 15 days, it's a pretty slow progression across the Pacific Ocean. The Indian Ocean, starting first here, near India, and then moving slowly here to north of Australia. So if that's the slow progression of the MJO, what can we historically learn from that? So we come back to a few things we keep discussing. We do still have a weak La Niña, and if the MJO goes to phase 3, historically that means that ridging along the west coast is a bit more rare. We tend to have more ridges that want to move back to the west with time. Now, I know that I have been watching for this now, it feels like for about 5 weeks to occur, and the models have persisted and not shifted the ridge. We're going to ask the question, is it going to happen now? But what this ends up giving us, is a better return of moisture to the west, a very active pattern through here, ridging over the southeast that extends to the North Atlantic. I mean, this would be a setup for, well, not a miracle March for the west, but a decent one. This would be a setup here in the Midwest for an extremely wet March going into the Ohio River Valley, the eastern Great Lakes, and into the Northeast. And with the ridging over the south, that would tend to be drier and warmer. So we say all of that, and we go out and look at this forecast. Now, this is March 1st. You're looking at the 500 millibar height field, so troughs and ridges. Now, certainly the ridge is still too close as of March 1st to the west coast. But as I play this forward, going out here into the first week of March, second week of March, look at what the models are doing. Did you notice it? They're putting the highest height anomalies right where we would expect them if the MJO stays over the Indian Ocean or even moves north of Australia. And if that's the case, then the flow can come around it and come in to the west, not avoid it, come across the U.S., and then run up over a ridge that's sitting in this area, pulled around lower heights over the Arctic. This would be a very positive signal from the Arctic Oscillation helping this whole pattern out, which means it splits north-south. All the cold air will be north of that line, and all the really warm air will be to the south of it, and we'll really have a contrast. And right on the contrast, that's where all the action is. So I show you that, and I'm going to say, let's look now at the precipitation anomalies. We better zoom in here. This is how things are shaping up. Let me get you to the whole of the month of March. You see, when you look out there, we see better precipitation in places in the west. At least it's not bone dry anymore. We then see very active in through this corridor. And even at times throughout March, if I kind of take you week by week, I'm going backward in time, but that's okay. It looks like as we get out there toward the equinox, we could have at times better moisture returning to the west, decent moisture here in the mid part of the country where we need it, and above average kind of where we don't, which is from the mid-south through the eastern Corn Belt. What about those temperatures? Well, let's just step up here. We'll go to a 30-day temperature anomaly graph, and let's look again at the whole of the month of March. And again, coldest air is anchored here, over the west, but at times we'll see, we'll see quite a bit of warm air that will show up in this region as a result of this pattern setting up. So I look at all of this, and I see a major difference between this year and last year, and has a lot to do with the tropics, and finally a connection with the polar regions where the AO is going very positive, the NAO is going very positive. And all of that's going to start to trickle through the forecast as we move forward. So if that's my update on the long range, including a little forecast verification from last year, this is where we are right now. So for the first time in a while, there's a trough that is cutting through the Pacific Northwest. You see the flow screaming across the Pacific. We talked about that last week, and then it splits here. One piece north, one piece south. The major difference is this high over low break right here, this high over low pattern, this Rex block, that's what we call this, is no longer sitting on the west coast, especially this big ridge. It's moved into the Gulf of Alaska. So the pattern is split, and there's actually a component of the subtropical jet here. And what I'm going to talk about is I'm going to show you that this pattern will likely begin to appear to retrograde to the west, but really what it's going to do is going to redevelop into a whole different scenario as we move forward in this forecast. Now, what you have to watch if you are east of the Rocky Mountains is this little wave right here and this one right here. Now, what's going to happen is this wave is going to go rapidly over this ridge and dive right here. And it'll take that same amount of time for this trough to go from here to Arizona. And the one that comes in on the back side here will help propel the one that's out ahead of it straight through the Midwest. And this one's going to linger back here for a little while. And what that's going to do is that's going to set us up with a pattern that's going to produce another multi-day winter storm event in the midsection of the country. The models are not in agreement over this just yet. Now, they both have this system, but it's the placement and intensity that's very different. So what are you looking at here? Well, you're looking at the wind field about a mile above our heads. And the low is located right there. Now, the height of that low in the 850 millibar field is about 1380. That's 1,380 meters. And there'll be a front right here. See where I'm drawing it? It basically goes from like Joplin, Missouri, through St. Louis, right through Indianapolis, and on its way out here to this part of Quebec. On the south side, we're just feeding this with lots of strong winds and very warm air. Now, keep that in mind because watch where the GFS puts things. So this is the European. The GFS is here. It's about 150 miles farther to the north. It's also substantially deeper, which means that the front is much farther north. Now it's going through like Springfield, the Fort Wayne, through Detroit. And that means that the southern side of this is going to have more warm advection getting farther to the north, and it's going to change the precipitation type. It's going to change where the heavy snow is. And that's the current difference between these two systems. It's the amplitude of the wave, with the GFS being much stronger and much farther to the north. So what does this all mean? Well, we need to get in here and take a look at it piecewise. Certainly on the south where you open up the Gulf with unstable air, by the time we get to Wednesday, we're going to be watching out for a big area here along the Red River Valley, getting into parts of the Mid-South. And then on Thursday, this is going to translate east into this region. So we're going to have severe weather threat across the south here. This will be an all hazards type severe weather threat. We could get straight line winds. We could get hail out of this, although that's, I think, the smallest of our concerns. But there are going to be enough wind shear with this to possibly produce tornadic thunderstorms. So we have to watch this whole region on the southern plains to the mid-south Wednesday and Thursday this week. To see that taking shape, let's do our multi-model analysis here. I've got the GFS on the left and the European on the right. All right, so the wave is moving through the Pacific Northwest today, spreading some snow in that area. We watch two things happen between now and Wednesday at noon. First, the northern wave breaks off and becomes a low right here over the Hudson Bay. Both models have that occurring. At that same time, there is an Arctic high right here sliding into the northern plains, and this is unfortunately what keeps the northern plains dry. The frontal boundary sits right there in both models at this point, almost the same position. And there's a big high here, it's also in both models, that's feeding all of the warm, moist, unstable air into that front. This is why we're going to watch this area for storms to blow up. Now, this is noon on Wednesday. We can see the snow pushing here in the front range, snow in Ontario and Quebec, and rain. This is going to start off as rain in parts of Missouri, Illinois, Iowa, Wisconsin, Michigan, right in through there. See this? So this will be the evening hours when we're going to watch those storms explode in this area. But already you can see the model differences, can't you? Look at how much quicker the GFS is at developing this system, moving it farther to the east, where the Europeans a bit later. We go to the next frame. Look at where the snow is on the backside from the GFS compared to where it is on the ECMWF. Now, they're both putting down a lot of heavy rain in this area and storms to the south, but this is 6 a.m. Thursday. There's Friday, midnight Thursday, Friday morning. This is Friday morning. Now, what I tell you, the GFS quicker, farther to north, stronger, brings much more snow in this area. Look at where the European keeps it. Big differences in the Midwest here. Severe storms to the south. Both models have that. But this is 6 p.m. Thursday. We're going now into the overnight hours into Friday morning. That pulls into the northeast. And because the European's slower, farther south, look at the snow that we're going to see in the northeast compared to what the GFS is doing. Now, both models bring in another clipper behind this right here. And that clipper then moves over the Great Lakes as the front finally kicks out east. And we'll take a look at the rainfall totals and snow in just a moment. But then I want to show you this. I'm just going to play it through the weekend. They both dip another system into the northwest. And as that system comes in, It develops in the midsection of the country, some point middle of next week, Tuesday, Wednesday, Thursday. So we've got one happening at the end of this week, and not only is this in the operational runs, but the ensembles are also attempting to produce another system here. Now, what I will be watching most carefully for is where this wave ejects. Does it come out of Colorado or does it come out of New Mexico? You see, the European model wants to bring it out of New Mexico and then take it into the Ohio River Valley. That limits the moisture return here. The GFS, again, is farther to the north, and it brings better moisture in the form of snow over an area that desperately needs it. But the thing is that in the next 10 days, we have two systems that could potentially be quite active and multi-hazard. And all of this is because we finally eliminated flow out of the northwest, and now we're bringing it out of the southwest. See that difference? All right, so let's talk about a few of the different parameters. We're going to use the GFS model first. Now, this is the operational run. I'll show you ensembles in a few seconds. Clipper system, the low. Now, look at where it puts the heaviest snows. Kansas City, through the Quad Cities, through Chicago, and right through the middle part of Michigan over into Ontario. Also brings in heavier snow in the Cascades. That's the GFS. This is the European. Similar in the west, different in the intensity of the clipper, and the snow band is much farther to the south and very narrow. So I'll show it to you again. That is the GFS. This is the European. The difference in the snow band is it's the width of the snow band difference. Do you notice that? That's impressive, the model differences. We got a pretty good battle going on here. What do the ensembles say? Well, the European ensemble paints a path right down the middle. This is the probability of getting 3 inches of snow through the next 7 days, And you can see that it comes basically from the panhandles through parts of Kansas, Missouri, Illinois, right into southern Michigan. That seems to be the corridor that both the ensembles from the European and the GFS are picking up on. Of course, this is the clipper path, and we're getting good snows finally in the northern part of the Rockies and the Cascades as well with that pattern shift. All right, we have another aspect of this storm system, and it's ice. The first system possibly delivering ice in a few different bands as the front progresses. So why does it look like it's a band? Well, because the cold front on the backside is moving with time, and it's just running under. The warm air is running over the top of it, giving us these multiple bands of ice. And that second storm system, the models are very aggressive on the ice accumulation from that one as well. Now, we don't have the details on this one, okay? But that second system, Tuesday, Wednesday, Thursday of next week, has to be watched carefully as well. From there, let's just take a look at total precipitation. I'm going to use the European model on this particular example just to show you that where the storms are coming through, we are talking about 3/4 of an inch to over 2 inches of rain. And the heaviest region right in through here will possibly pick up better than 2 inches of liquid equivalent. Remember, some of this is coming down in snow. And where does that second system come from? Same area, which means just based off the European model, the next 10 days, there's going to be a region right in through here that has a high probability of picking up 3 to 6 inches of rainfall. If the GFS has it, better precipitation back here. That's the US model. And when are we going to get the breakdown in the west? Well, remember, the models are starting to do that much later into the month, in the beginning of March. All right, let's see when that might possibly get here, because this is day 10. This is day 8. Let's fast forward it to day 10 and into the week following. You see the models out here as we pull in fully into week 2 are starting the shift of that ridge we talked about at the beginning, bringing in better flow. But the net effect of this is that that second storm system dominates the precipitation pattern when you look out there at week 2. It doesn't matter if you're looking at the European or at the GFS, they both say the same thing. What will likely happen after this is we'll finally see improvements in this region. Well, mostly northern California into the Pacific Northwest. That's when I think the shift will be on. From there, let's talk temperatures. Now, I just made this. There we go. This is what we've seen so far this year in terms of temperatures compared to average. And so much of this has been caused by the ridge that was over the west and the northwest flow coming like this. So all that cold air in the Great Lakes into New England, but mild coming off of the mountains here. This is where we've also missed out on some snow. This pattern's about to change. Over the next week, we're going to see a pretty highly volatile, temperature pattern. This was Monday's highs. We've already seen these. Tuesday, very mild in the midsection of the country. This is all out ahead of that system. Wednesday, there's where the front comes slicing through. Go from there into Thursday. Cold air pulls in, snow on the backside. This is a good setup for that system. Very, very mild into New England. But by Friday, the front advances, and already behind it, more mild conditions are coming in. This all starts to break down and shift around once we get out there to the day 5 through 10 time period. So what we're looking at here is that time period. Notice the warmth you see in this area. The cause for that is the building of a ridge in this area. So instead of the flow doing this, the flow is now doing that. And that's what's going to set up that next system. And you go out there day 10 through 15, now we're starting to see the colder air in place here, which means the jet stream's got to go around that. And that's what we're seeing. It's a great shift overall in the pattern. It's helped by the Arctic oscillation going positive. It's helped by the shifting ridge. And I'm feeling more confident about returning better moisture, especially to Northern California, Oregon, Washington, and the mountains in the west. All right, from there, I want to show you what's going on in one other place around the world, and that is Europe. The next 10 days are extremely mild throughout much of Europe. The Black Sea is here, so this is Ukraine, this is the Russian wheat belt. You can see how mild things are going to be compared to normal. And I was just thinking about this with respect to snowpack, because we have to be aware of these big warm-ups in winter that melt all the snow. For example, this is right now, if you look at Ukraine, we only have snow in the northern part. This southern part of the Russian wheat belt, uncovered in snow. This is all cloud down here, by the way. And why this is important is that, a year ago, we had a whole lot more snow on the ground. See how much more snow was here? It's not, some of this is high cloud. This is high cloud, but you can see the white, the snow. What I'm just talking about here is that if, and this is just a big if something leaves this all, if the snow's not there and it's uncovered, and then a big weather system comes barreling through here and drops the temperatures off without the snow cover on top of the winter wheat, that could be a problem that we need to be paying close attention to. So I'm going to be watching this carefully throughout this region just to see if there's a story coming out of this part of Europe. All right, I'm going to wrap it up there. Appreciate your attention, and I'll talk to you again on Thursday. Thank you.